Hi, today we will explore an interesting and useful concept in data structure, an algorithm, the circular queue, an efficient approach to the queue management. Firstly, I will brief myself. My name is Varun Padia, and I am a first year CSC AI student from Techno India University. What is a queue? Before we jump into circular queue, let's quickly review what a standard queue is. As we can see from the image, a queue is much like a line of people waiting for tickets. It's a linear data structure that strictly follows the first in, first out FIFO principle. Think of it like a line at a checkout counter, where the first person in the line is the first to be served. The two primary operations that can be performed in a queue is in queue and DQ. In queue is to add element at the rear part of the queue, and DQ is to remove element from the front part of the queue. However, a significant limitation of a traditional queue is wasted space. The front portion of the array can become unusable after several DQ operations, and an NQ operation can fail even if the space is empty in the array. This limitation of linear queue brings us to the circular queue, a solution designed to tackle the wasted space problem. A circular queue is essentially a linear queue, but it's implemented in a circular fashion. This means the last element in the queue is connected back to the first element, forming a continuous loop. Its main benefit is that it directly solves the wasted space problem found in the linear queue, thereby avoiding those inefficiencies. What is circular rotation? To understand how a circular queue works, let's explore the basic idea of circular rotation. The image clearly shows a circular arrangement of elements. The important part is that an element removed from one end of the circular sequence are added back to the other end. It's like a constant motion of machine for data within the allocated space. You can see the result after rotating it for one time that the element has shifted position while preserving their relative order and overall structure. This mechanism ensures that the overall size and the relative order of the element remains constant within the sequence. This wrapping around feature is a sequence of why circular cube is so good of reusing memory and avoiding the wasted space issue of the linear cube. Now that we have gone through the concept, let's quickly look at how a circular cube is implemented in code. This section will give you an overview of the practical side. We will cover the structure definition, function declaration, and then briefly touch upon the key function implementation and an example of the main function. For our C implementation, we will include the standard input and output library stdiu.h and the standard library stdlib.h, which provides function for memory allocation. Here's a basic structure definition for the circular queue. We are defining a structure circular queue and releasing it to CQ for convenience. It contains int size to store the maximum size of the queue. Int F for the front indicating the first element and int R for the rear indicating where the next element to be added. And array and ARR, a pointer to an integer array which will hold our queue element. There's the function declaration for our circular queue operation. We have insert CQ to initialize and set up the queue, is empty to check if the queue is empty, is full to check if the queue is full, enqueue to add an element to the queue, dequeue to remove an element from the queue, and print CQ to display the element in the circular queue. Here's a snippet of insert queue function. It's responsible for dynamically allocating memory for creating a circular queue structure. We use a scala function to allocate memory dynamically. Here we take a variable temp and the data type CQ to create the structure of the circular queue. In the scala function, we give the size of the data type and then how much dimension we want. As I want one dimension, so I have given one here. Then temp of size, we will give the size of the array we want to create. temp of array, the temp of R, we will initialize it with -1 and same with temp of F. The R here is denotes the rear position and F denotes the front position. Temp of array here creates dynamically here creates the memory dynamically of the size that the user has given. Then we will give this temp to the star S. That's all in the insert Q function, CQ function. Then here's the code, here's the snippet for the is empty function. In is empty function, we will check if the rear position is same as that of the front position. If both of them will be same, that means the that means the queue is empty. The circular queue is empty. If not, then it will return 0, and if yes, it will return 1. Here's the same with its full. Full with check is queue is full or not. If it will check through if the runner position and the size that the total size the user has given -1 both are equal, then it is full, which will return 1, and if not, it will return 0. Here's a snippet of enqueue function. The enqueue function which is used to add value to the circular queue. In enqueue function, we will first check if the circular queue is full or not. If it is full, then we will print the message this circular queue is full, and if not, then we will perform operation on it. We will add the user given value to the circular queue. In this, we will change the in this, we will change the error position by 1, and we will also perform a special operation of modulus of q of size to reuse the to reuse the empty memory created by the DQ function at the starting position. If the error position is uh, if the error position plus 1 is equals to its size, equals to the size given by the user. Then we will print the message of include element and the element which is given by the user. Here's the same with the DQ function. In DQ function, we will remove an element uh, from the circular queue. Here we will create a variable a of data type int, which will be initialized to 0. Then we will check if the circular queue is empty or not. If it is empty, then we will print a message if this circular queue is empty, and if not, we will perform operation. We will take the value of the front position in the circular queue and store it in A, and we will change the front position. We will change the front position by 1. And here, as it is a circular cube, we will perform an additional operation of modulus q of size in the front position calculation, which will change the front position if it is uh, equals to the size. If the front position plus 1 is equals to the size of array that the user has given. Then we will return the value of A, the value stored in A, that is the front positioned element in the circular queue. Here's a function of print circular queue. In print circular queue, we will print every element one by one by taking the help of a loop. In the loop, we will take variable I, the loop variable, which will uh, which will be initialized to q of f, the front position in the circular queue, and it will run till the rear position of the circular queue, and it will increment every time by 1. It will print the uh, it will print the element that is it will print the ith element in array, that is the front element. Then here's the code of the main function. Main function. Here's in the main function, we will use the structure s equals to null. Then we will create three variables of data type int, size, ch, and data. In size, we will store the size of the array. In ch, we will use to take the choice from the user to exit enqueue, dequeue, or print the circular queue. And in data, we will take the data from the user to input it into the circular queue. Then we will take the user input of size. Then we will run the insert CQ function. When we call the insert CQ function with the address of S and the size that is given by the user for the array. Then we will use a do while loop, which is a special type of loop which runs one time necessarily without exiting if the condition doesn't meet also. In this loop, we will give all the options to the user, like 0 to exit, 1 to enqueue, 2 to dequeue, and 3 to print the circular queue. Then we will tell the user to uh, tell the user to give their choice. Then we will take the choice using a scanf function. Then we will use a switch case in which if the user inputs 0, the case 0 will give, the case 0 will print, the case 0 will print, thank for using the circular queue operation, and then the break statement, so that not all the cases will print. The break statement is used for that only. Then we will use case 1, in which if the user inputs choice 1 to enqueue an element, then we will ask the user to input the data. Then we will take the data in a scanf function. Hmm. Then we will call the enqueue. Then we will call the enqueue function by using the s and the data. The s is nothing but the structure, and data is the input that is given by the user to get it done in the circular queue. Then we will print the statement data enqueued in the circular queue, and then we will use the break statement. Then in the second case, that is case 2, which is used for DQ function, I will ask, not ask, I will simply call the DQ function and print it and break the statement, break the case. And then in the third case, that is print circular queue, I will print the circular queue one by one by calling the print circular queue by passing the structure S in it and breaking it. And if the user has input anything else apart from 0, 1, 2, and 3, then I will print the invalid input message to him. Then I will check, then the condition for the while will be while ch not equals to 0 until the ch is not equals to 0, continue the loop. And if it is equals to 0, then exit it. But as it is a do while loop, it will run for one time necessarily and then return 0 and then close the bracket and the main function is done. Now look at what this all means in practice. This slide display an example of program output demonstrating the NQ and DQ operation and how the circular queue handles the capacity efficiently. You can check out the output that I have done for you. I have done I have taken an array of 5 elements of size 5 and then 6 NQ and 2 DQ and the performance is great. It has taken the 6th NQ also, not showing that the circular queue is full. Now let's go to the VS Code and check out the code there. running it in front of you, with showing you the difference with queue also. Let's check in front of you in the VS Code, running the program in front of you. Let's say I am taking the size now to be 4 and enqueuing one element to be 45, then again enqueued 55, then again enqueued 65. Now I am dequeuing twice. Once it gives 45, the first element, then now it should give 55. Yeah, it is giving. Then I am going to enqueue another element, 75, and then another element, 25. And then once more I will enqueue element to be 95 and show you the display, show you the outputs. Let's check. It's 65, 75, 85, 95. I've enqueued 6 times and the size was of 4 only. But this cannot be performed in normal linear cube. It can be only performed in circular cube. As the extra space that was going to be wasted in the cube is not wasting in circular cube. Let's check with same with the cube also. In Q, I am entering same inputs like 45, again 55, once again 65, and then DQ twice, and then I am also entering 75, then again with 85, and we can see the queue is full. The pop-up appears, the queue is full. Now no more elements can be put. But if I will show you how much elements are there in queue, for this price, that is one only. So this is the limitation of linear queue. That's why the circular queue is more efficient as it stores more elements in the same space, which was going to be wasted in linear queue. That's all from my side. Thank you for your attention. I hope this presentation gave you a clear understanding of what circular queues are, why they are beneficial, and how they address the limitation of linear queue through efficient space management.